Day 8, we'll take a look at these sequences that we've been studying, arithmetic and geometric, and look at them in context. So first we're going to start with the warm-up. Are the following sequences arithmetic, geometric, or neither? So if we take a look at the first one, at first glance it appears arithmetic. How do we get from -8 to -5? Well, we're going to add 3. How do we get from -5 to -3? We're adding, but now we're adding 2. And the same with -3 to -1, we're adding 2. So even though we're adding a number every time, since it's not the same number, it's not considered arithmetic. A common difference would be the same number every time. So this would be considered a neither arithmetic nor geometric. Let's take a look at the second sequence. So we have 5, 10, 20, 40. And this one is multiply, and it's multiply by 2 every time, and so this would be a true geometric sequence. Goals today. You'll be able to read a situation, determine if it's arithmetic or geometric, write the explicit equation, and solve. Also, we're going to focus on when do you start with the 0 term versus when you start with the first term. So here's the first question, or problem. You run 2 miles the first day. Okay, so we have day and we have distance. I like to put my information in a table. It's just easier for me to see. So the first day we run 2 miles. The second day you run half a mile more. So that's 2.5. The third day a half a mile more. So here we can see that we're adding half a mile every day. So that would be arithmetic, and the common difference would be 0.5. So the explicit equation, again, you should be thinking slope and y-intercept. Y equals mx plus b. But if you write that in recursive or explicit notation that we've been using, we would say, all right, a sub n, to find the number of miles run any day, you would take, let's see, you would add half a mile for each day that you run. There's the slope, 0.5n. And then 2 that you would add your initial value, which would be the y-intercept or at day 0. So we do have to imagine if there was a day 0, how many miles would we run? So that would be minus 0.5. So this would be 1.5. So again, if you are using something that's arithmetic, you want linear slope and y-intercept, and the y-intercept would be at day 0. You would run 1.5 miles. So what this means is you start at 1.5, and every day n that you run, you add another half mile. So then the last part, find a sub 14, just means how far would you run on the 14th day? So with the explicit equation, you can just plug in 0.5 times 14 for 14 miles. Plus 1.5. And so if we solve this, half of 14, that's what this means, is 7. And 7 plus 1.5 is 8.5. So on the 14th day, if you kept this rate up, you'd run 8.5 miles. Problem 2, you open a savings account that gives you no interest. You put $350 in it. Each week you deposit $75. How much money would you have 12 weeks after you open the account? So again, if we make our table, we have time and we have the amount of money. So when you're investing money and you deposit it, that's times 0. So times 0, we start with $350. And then every week we add 75 more. So that would be $425. And then week 2. Would be $500. And again, the common difference here, we're adding $75 a day. So this is arithmetic. And if it's arithmetic, we need the slope and the y-intercept. So here the slope is we're adding $75 per, not day, but each week. And here it does give us the y-intercept at times 0, so plus 350. So there's the explicit equation, which means to find a sub 12, we could just plug in. And we would say, all right, for the 12th week, it'd be $75 per week for 12 weeks, plus the $350, and then you would get the total amount. All right, so you can plug that into your calculator and solve. Problem 3, you invest $150 into an account that pays you 2% annually. Assuming no deposits or withdrawals are made, how much money will you have 13 years after your initial investment? All right, this one's geometric, so I'll show you how, and then we'll talk about how you set it up. So again, you have time and money. And again, we're depositing $150. Oops, I put that in the wrong spot. So times 0, 150. All right, after 1 year, you make $150 plus the 2% more. And so really we're going to multiply by 1.02. And the process behind that is we're going to take 2% and change that to a decimal. So you divide by 100 or move the decimal place over twice. And then since it's increasing, we're going to put a 1 in front of it, which takes 100% of the year before and adds 2% to it. So if I multiply that out, 150 times 1.02, that's $153 we would have. And then you would take 153 and multiply it by 1.02, and you would get the amount after 2 years and so on. So we're multiplying by this ratio of 1.02 every year. And so here's the explicit equation. So if it's geometric, you start with your starting value, 150. We multiply it by the ratio. Here it's 1.02. Again, 0.02 is the percentage. We add the 1 because we're increasing. And we started at times 0, so this is n. And so to figure out the last part of the problem, a sub 13, it would be 150 times 1.02 to the 13th power. Let me type that in my calculator real quick. Okay, so that would be $194.04. So even though you only invested $150, you've made like $44 then after 13 years just off interest. All right, our last problem, you rent an apartment, it costs $1,200 per month for the first year, but the rent is set to go up 11% per year. If you stayed in that apartment, how much would it cost you per month that 8th year? Okay, so if you make our table, we have time. The X right there, I guess. And we have money. And so the first year the rent is $1,200. The second year we take that $1,200 and increase it 11%. So an increase of 11% is 0.11 for 11%, and we add a 1 to it. So this is our common ratio. So we're going to multiply by 1.11. So 1,200 times 1.11. That would be 1332, multiply by 1.11 again, and that would be 1478.52, and so on. So you can see the table, but if we write the geometric explicit equation, we have our starting value. It's going up 11% per year. Oh, but we start at time 1, so we need to do n minus 1, and that will take into account like multiplying between the first and second year, not between 0 and 1. So here's what it looks like. And then if you plug this in, it would be 1,200 times 1.11 to the 10th power, because you'd plug in 11 minus 1. And so if you type that in, you would get, ooh, rent's expensive then. You'd be paying $3,407 a month, which is super pricey. So you'd probably leave. All right, so here's the summary. To find the common difference, take one number and subtract the one before it. The recursive rule, a sub 1 is your first term. And then the explicit rule, you're going to put your common difference times n plus your 0 terms. You have to remember to go backwards. Think slope and y-intercept. And then for the common geometric, to find the common ratio, take one number and divide the one before it. Again, you need the first term here. And then there's 2 ways to do the geometric equation. You can do the first term times the ratio to the n minus 1 power, or to find any number, you can take the 0 term times the ratio to the n power. Ooh, this is recursive. Okay, so, all right, we're going to redo this. So for this one right here, recursive is taking the previous term and then you add your common difference or subtract it. And then for if it's geometric, you multiply by your ratio. So that's what I should have put there. But then for explicit, to find any number, again, it's the common difference, which is your slope, times n, plus your 0 term, or y-intercept. For explicit, it's the first term times the ratio, the common ratio, to the n minus 1 power, or the 0 term times the ratio to the n power. So your assignment today will be on Delta Math, and we're going to practice with these equations and solving. One hint is if you had something like this, you start at 100, you double it every time. To type in the n minus 1 as an exponent in Delta Math, you're going to use Shift 6. Shift 6 to type that in. All right, so that is it for notes. If